Well, good morning, everyone. Good morning, good morning, good morning. I'm so excited to be here. It's my first time at NDC Sydney. I'm really excited. It's my first time in Sydney. Yes, I know. I was really afraid to come to Australia just because of Australians. But you guys so far have been pretty good. All right, enough stupid jokes. I've got a lot to get into today. I'm going to talk about this thing I've been building for the last 6 months. I'm going to skip the preamble of all the things of why I'm building it, whatever. I'm going to touch on some of the technology, but basically what I want to do is I want to focus this talk on nerding out and geeking out. I mean, it's kind of unstructured. It's just going to be me saying, woo, look what I made. However, it's not even a prototype. It really is kind of just pre-alpha, if you can say that. I've been making stuff because I want to see what's possible. I want to see what I can do with Postgres. I want to see what I can do with Express. I want to see what I can do with Vue. And I want to build this thing that I really am struggling to define. I named it Velzy, but it's a front-end application. And I used to call it a CLI for your API, which doesn't make any sense at all. My friend Damien Edwards, who's here today too, he said, oh, it's a backend-in-a-box. That's my best Australian accent. I'm not going to try it again, I promise. Thank you. Shut up. OK, you're in my, never mind. Otherwise, it's also called a bucket of buzzwords, because I've got a bunch of stuff in there. So you're looking at the screen right here, and it's a Vue app. And it's supposed to kind of just be a back end for whatever front end app you're building. And it's supposed to do, well, lots of fun things. I try to say it's kind of like Firebase, except it's Postgres. If you've ever used Firebase, anybody here use Firebase? Yeah, Firebase, we love Firebase. Firebase is awesome. I've used Firebase for years, and I really like it. I've used it for a lot of things, and I kind of miss it now that I work at Microsoft. That's not funny. One of the things that I wanted to do just a quick whirlwind tour of what this thing has and is and does. And so because we're working with data, we have to have the obligatory data explorer. So you can see, here's your records. You can go click on them. You can edit them. As you can see, it's just a JSON document. I'm storing JSON in Postgres. That's not terribly exciting yet. It's got a full GraphQL interface too, so you can work GraphQL, you can work REST if you want to. And the database, as I mentioned, is JSONB. This is just pure Postgres. There's nothing exciting or scary there. Because I mentioned the real-time already, I have to give the obligatory real-time demo, which is not working. Video is not playing. OK, that's not fun. Why isn't this going? Because I have to click. Yeah. What do they say here? Yeah, no. All right. That sucks. Is it going to go? There it goes. Hey. All right. So right now, I don't have any tables in the database. I'm using Postman, which is a really cool API tool. I'm posting to the products table, which doesn't exist. You guys can know what's coming up next. I showed this to Damien Edwards, and he says, let me guess. The UI is going to update in real time. Like, exactly. So that's kind of cool, though. So the table was created on the fly, and blah, 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 blah. But here's the cool thing about it, and this is where we get to nerd out and geek out. I zoomed in a little bit on what I just did, and what is in the forefront here is Navicat, which is just a database explorer. It just looks right at Postgres. I'm not going through any API or anything. And in the background is the UI. And so that time it worked. Here I'm going to update the record, and then if I skip away, of course, this is a real-time demo, but that's just the database. I'm not going through a server to get that real-time. The database is doing that, and I think that's pretty cool, and I've never seen that done before with just pure Postgres. Does that make sense? Like, it's just like running an update query and having it bang out to a UI. Here's another thing that I think is really neat. Now that we have a record, we might want to search for the stuff that's in the database. You can just use a keyword, and you can do full text search over JSON documents. You can't do that in Firebase, which I think is pretty cool. You can't do that with FaunaDB. You can't do that with a bunch of other online systems, like what's the one I was thinking of, Cloudant. You can hook them up to external services, but I want it all built in. All right, well, as I mentioned, I showed this to Damien Edwards, and his reaction was pretty typical. Why would you do this? Why, Rob? Why, Rob? Why, Rob? Why? This is my nightmare working with this guy. I love Damien. He's a really good guy, but he tends to get right to it. And my answer was, typical me. The cool thing, this is my job. This is what I do. I work at Microsoft. I'm in the Cloud Advocate group. And one of the fun things is that lot of people think that all we do is go around and talk on stage like I'm doing right now. But we actually, my part of the job, I work in an engineering group where we actually write code and try and speak to developers in terms of code and open source projects and other things like that. So I am building this as a way to help developers do their jobs better, have more fun, and then also, as you see at the very end, maybe work with Azure a little bit better, and I'll show you that at the very end. So really, why did I build this? Why did I want to do this? Has anybody here used Vue or any kind of the, yeah? Do you guys like the new up and coming front end frameworks? Well, they all come with a CLI, and that CLI is insanely powerful. I was blown away. I think it was 6 months ago I climbed back into using Vue, because normally what I would do is I just download the library or get a script tag, throw it on the page, and start working stuff like, okay, let's make that thing explode or move around or whatever. And then a friend of mine, Burke Holland, was like, Vue can do a lot more than just orchestrating events on a page. And he showed me the CLI, and he showed me a bunch of other frameworks, and I was like, what? It comes with its own server. You've got plugins. Like if you want to make something look better, work better, have persistence across the entire app, it's crazy what these things can do, and I was just absolutely blown away. There's this other framework called Nuxt, which is a framework on top of Vue. And it is kind of opinionated, but it gives you all kinds of things, including server-side rendering, which is weird. It chunks out your JavaScript, delays. It makes it so the front end, when it loads up, doesn't take forever. And so if you go to individual pages, it just chunks out the JavaScript, sends it down. It's amazing. The experience is awesome because it's focused on the front end of the application. That's what your user cares about, so that's what the team is focused on, is those requirements. You build out the capabilities, and then later on, you might hire a dev person to come and build the back end for you. But as you're building these things, you need to store data. You need to somehow work with persistence. So how do you do that? Well, I learned this trick from the Vue Mastery folks. That's it's Adam Jar and Greg Pollack, who used to run Code School. And two of my very favorite people, I'm so envious of Greg because he's so good. They created a site called vuemastery.com, which shows you all about Vue, and it's great. And one of the tips he said is to use this thing called JSON server. And what it does is it stares at a JSON file. And that JSON file has some keys and some data. And whatever keys and data you have in that file, it will just create a REST API and store the data and so on. So it just mocks out a backend API that stores data in a file. That works great. It's pretty cool to see this because it focuses your front-end developers, or just developers now, 100% on building an application that's relevant to your client. And they just don't worry about the backend because the backend doesn't matter. At some point, it'll come along. There's also a real-time database that you can use at Firebase, right? So you can have something that's a little bit more orchestrated with a system that you might go live with. So this is Firebase for those who haven't seen it. As I mentioned, it's a real-time database. They also have Cloud Firestore, which is a massively scalable key value store, which is amazing. Firebase also has free hosting for static pages. So you can send your stuff up there. There's secure file storage. So if you want to deliver things like I do, like books and videos, you can send stuff up to Firebase. Serverless, woo! So you can have little functions in the sky. They have user authentication, and my God, they have everything. So this is what I meant. Like, this is what I was trying to make. When I started, I was trying to make something like Firebase, but you might be asking, well, why don't you just use Firebase? Why would you want to recreate what's already been made? And the answer is, I have things that I want to do. What about me? Where am I in this? I don't mind my data and my app living in the sky on some service. It's not that I distrust Google. Why would I? Oh boy, yeah, Microsoft employee says he distrusts Google. That's nice. It's not what I said. It is what I said. Anyway, I don't trust any service. That's the truth. I don't trust any service to hold my code and my data because at the end of the day, I want to own the entire experience. So I have built and maintained, I'd say 5 or 6 apps for my own over the last 10 years or so. And every time I've run into the same problem. In the beginning, I am focused on, I need to get up, get to market, get out, get to market, get out, get to market, and all that crap. And then I do that. And so I'll use a system like Firebase, I'll use WordPress, I'll use whatever I can to get things up and running. But eventually problems creep in. And you have to answer customer queries, you have to do support, you have to do all kinds of stuff, and then you fix and change things. And you're like, I can't really do it because WordPress plugins is going to not like the boop. And it's really a pain in the butt. So basically, what I've come to realize is after a few years, what really, really matters is control. I want as much control as I can have. And that, in my experience, has sometimes run afoul of using online services, platforms, and whatever. So what I really want is I want Postgres, I want Express, and I want it my way. I want the simplest possible experience I can build. I want something that I have control over, but also that kind of helps me along, as Firebase might, but then that I can expand later on. That is the goal of why I'm building this. Complete control. OK, so that's the quick look at Velzy and what I'm trying to do. Now I get to geek out, nerd out, and show you how I put it together and how I made it all work. And none of these are good ideas. I love the quote in the beginning because I like the idea of being foolish, of just not caring, because I'm at that stage right now. I just don't care. I just want to see what's possible. And you're going to see what I mean by that in just a minute, of how I'm making this all work. And I do hope someday to open source this and turn it out for people to use. So the first goal that I had in mind, the first goal I was thinking about are the people, it's for the people that are going to use this. The goal is to make this as simple as I can. So I want API parity across every level. I want you to be able to use this on the server using the same set of methods that you might on the client or maybe in the database itself. So I have these core methods, and I'm so focused on trying to keep things simple. I didn't want any more than this. Just something that you can do to operate with a document, operate with the documents that are stored in Postgres. This is the client app that I'm building out right now. Same thing. I want to have just save. I want to have filter, find, and so on. That's going to be in parity with the server, so you can just bounce things back and forth. I also have functions. And this is the core of what Velzy is. It is a bunch of functions that sit in Postgres. And everything you're about to see, you have to keep in the context that Velzy is an extension that lives on top of Postgres. It's not supposed to be an app or a framework. So every function that you see here, I got some problems with the naming. I'm going to fix that. But they're supposed to be almost exactly in line with what you use in the server and what you use anywhere else. GraphQL, the names of the queries, also are the same. So that's what I'm going for. I'm going for parity that you can use throughout, well, wherever you're building things. OK, so get to the geek out part. I want to show you a fun thing that I had to learn. Since I'm building things on the fly, I kind of have to do stuff at a meta level with my functions. And I had to learn how to write a function that uses dynamic SQL. And that's probably going to sound like absolute bonkers craziness. Maybe it is, maybe it's not. SQL doesn't scare me. I love SQL. I love Postgres' version of SQL. It is anti-SQL, but they have ways of doing things with certain keywords and other things. It just makes life wonderful. And if you dig in and get to know how to use it, it's really, really fun. But I understand that as application developers, a lot of times you just want relational managers to deal with things, and I get that. So I do want to dig in, though. I want to show you. Has anybody ever written a function here? Why are you laughing? Is that funny? It is funny. All right, it's a little funny. OK. This is what a function looks like in Postgres. It's really not that scary, but it's a little bit different. And I know a lot of people don't want to write stored procedures and don't want to write functions and routines in a database because business logic and so on. I get you. I hear you. But when you're working on a database extension like I am, you kind of have to. But this is what a function looks like. You have create function. You got the function name. You've got the argument type and the argument itself. And then you got this weird as and then dollar signs, which looks a little bit weird. And those dollar signs are just delimiters. That just means here comes a string. Because when you define a function, you're actually defining the body of it as a string. But you can just ignore it because syntax highlighting will just let it go. So that's what those are. The interesting thing is at the very end is the language specification. As you can see, I'm using PL/PG SQL. It's a little bit funky, but it's basically just SQL with some control structures on it and some control flows, some conditionals, and so on. So that's all that is. You can also, if you want to, just use plain old SQL. You don't need to use anything crazy in there. You can just store everything and encapsulate everything in a function if you want to. If you're feeling really nuts, you can attach the V8 engine to Postgres and use JavaScript. I've done this before. It's a little bit strange, but it's kind of fun because JavaScript is a bit easier to write conditional logic in than, say, SQL. If you're feeling really crazy, you can also use Python. There's a bunch of other languages, including Perl, if you really want to torture yourself and write functions in a database with Perl. Oh, man. I can feel the red cards coming. I'm going to switch back to PLPG-SQL and kind of show you what the body of a function is all about. You have two sections. The first, you have a declare block, and then down below you have a begin and an end. That is a transaction space. Begin and end in a database marks a transaction. Everything inside happens in a transaction. So in Postgres, a function is a transaction. So everything you do inside of there, which is kind of nice, just happens within a transaction, and this is it. This is the skeleton of a function. And then what you write goes inside of there. So that's just the basics. I also want to show you how I'm storing the JSON. And again, I'm trying to keep this as absolutely simple as I possibly can. I just have a simple table in there, and it's got a single ID with a long or a big int, if you want to call it that, so you don't run out of space with your keys. Big serial is one of those keywords I was telling you about that allows you to create a auto-incrementing numeric ID. And here I'm just saying it's the primary key, and it's not null. This is where all the goodness happens. This is JSONB inside of Postgres. And if you don't know, Postgres not only allows you to store JSON, it allows you to store binary JSON, which is the same thing that MongoDB uses, or the same idea, at least. And that's nice because the JSONB can be indexed, which means you can run some really fast, interesting queries. And if you're wondering if Postgres blows MongoDB away, it does. By a long shot. The only difference is that MongoDB has a much nicer API, which I'm aiming to fix. The next thing we have is something I'm going to talk about more later on, which is the search field. This is what powers the full text search behind these documents. And the type here is TS vector. How's the name for that? The way that full text searching works inside of Postgres is it is actually a data type that gets handled on the fly in the query. You can store it as a document or a data type if you want, it's TS vector, or you can just do it on the fly, which most people do. But if you want something built super fast, then you could use TS vector as a column. And then we just have the timestamps. That's it. This is how the document is stored. Again, I'm trying to keep things as murderously simple as I can. OK, so how do we actually create this table? How does this table get created on the fly? This is my save function. I've obviously truncated it. I just want to show you the main part about it, which is that you can execute SQL on the fly within a function, if you want, using PLPG-SQL. You use the execute function, which is pretty obvious, but then you can do a format string. And this looks crazy. I mean, I showed this to somebody, and they said, man, you're going to get laughed off the stage. And I'm like, well, I need to do this. I don't have any other way that I know how to do this to create a table on the fly from within the database. So this is how I did it. So if you ever find yourself needing to do something like this in Postgres, that's it. The format function takes the %s, as you can see, public is the schema, %s, and then creates that table. This is going to be the real fun one. In my save function, later on down below, I'm also using dynamic SQL format function to create a trigger, which is, I'm proud to say, very foolish, but this is the thing that people hate about triggers, one of many, and I understand it. When a trigger goes off, a lot of people use it to go update something else, go change data in a table, go change data somewhere else, and they're almost impossible to debug because they'll just throw, and you won't know what's going on. Just say the query failed, and no one's going to know why. Until you're like, do we have triggers on that table? I don't know. How do you know if you have a trigger in the database? And then everyone looks at each other, and then it turns out, yeah, the DBA put a trigger on there to do something, and it's failing. And it's completely out of the developer's control, and I get that. I understand. But this trigger, oh, I have to say, this was Damien's reaction when I showed him the trigger. This trigger that I put in actually does something a little more interesting. Triggers don't scare me if they're doing something that isn't destructive and then won't throw an error. And I want to show you, this is the body of the trigger. When you have a trigger function in Postgres, you're handed a bunch of variables and settings. You get tgop, which is the operation. You get tgtable. You get a few other things, blah, 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 that you can reference. New and old. What's the change? So it's kind of cool. You can see what's happening at the time within the transaction. Here, I'm just checking to see what the operation is. What happened to the table, this document table? If an update happened and there's no change, so if the old body is indistinct from the new body, then I'm not going to do anything. But if a delete happened, I am going to execute pg-notify, which is an internal function that is going to send out a notification within Postgres. And same thing with add or update or whatever. A lot of people don't know this, but Postgres has pub sub built in. So you can, on a given connection, you can publish notifications, and you can listen, and you can react from within Postgres. So this is the thing. There's nothing destructive going on. I just have a trigger that's sending out notifications. That's all. And it's not going to error out. But I do want to show you how listen and notify actually work. This is pSQL that you can use to talk to Postgres in the command line. And once you have the command line up, you can see the name of your database, Velzy, and then you can use the listen command. So you just say listen, Velzy, and it's saying, OK, listen. Feels a little bit like Redis. In fact, it looks a lot like Redis. So here, if I send out notify on the Velzy channel and say hello, I get an asynchronous bump back. And it's that easy. It just has to be on the same connection. So then the question became, can I do this in code somehow? Can I have a dedicated connection, let's say in Node, using something like pgpromise, which is a library that I was using? I think you can do this with the npg-SQL driver. I want to say you can. I haven't used this in .NET in a long time. So here I'm just wiring up pgpromise, and it is just connecting to my database, and then I have a dedicated connection, and I also have a client on that connection. So the first thing that I want to do is I want to wire that client to listen for any notification that comes out. Now the driver has that. Here, the client is actually an event emitter inside of Node. So what this is going to do is it's going to sit and listen for a notification to pop out from the database. When that happens, I can do all kinds of things. Console.log, I can do self.emit and receive some data and send along the package. This is my Velzy listener class. It itself is an event emitter, so I'm just passing the event on up the chain. The very last thing I need to do is I need to initiate the query for listening. And that's what I'm doing. Listen to the Velzy change. So the connection is executing the query. Connection.none simply means I don't expect a result to come back. And it's just sitting there. And the client is going to be listening to any notifications that come along. That's that. Now, I thought this was going to take me hours. I thought this was going to take me forever. But it turns out that it just took me a couple of hours. And it's largely because of this person. This is the fun thing number 3, is open source. I love it. I know it's Vitaly Tomalov, who runs the pgpromise library. And he saw that I was working with his stuff, and he's like, what are you doing over there? You know, and I said, well, I'm trying to make your code work. And so he came over, and he actually jumped in and helped me out, put some things together, and also tidied up the code, which I love. So shout out to Vitaly. Thank you. So how would you make this work? So this is my app.js file, and I kind of wanted to show you how you just wire Velzy up to your app if you wanted to use it. So of course, the first thing is we need to require it. And then we just need to initialize that listener that I just showed you. It has to initialize the connection in the client, and it's going to sit there. Now we're real time, and we're just about live. We're going to use socket.io. Socket.io is going to talk to the client. Then I just need to pass socket.io off to a method to wire up the events so that socket.io knows what's happening. And then we're just doing server.listen. This is standard socket.io stuff. That's the wire events thing. And I'm not going to dive too much into this code. This is truncated, so it'll all fit right here. But the idea is I'm just taking the I/O from socket.io. This is the back and forth to talk over socket, or yeah, to talk over sockets to the client. And I'm saying, whenever an event happens on the listener, bump some stuff back and forth to the client. That's the entirety of the real-time experience. I went from a trigger all the way up the chain to a client, all the way up the chain now to Node and socket.io. And that's how this all works. I'd like to say it's not all that complicated, but I mean, doing real-time stuff on the web is it's not as easy as it could be, I guess. I don't know. There might be some other libraries to try and do this, but I was able to put this together in a few hours, and I'm very proud of myself. No need to clap. It's okay. I don't want you to. I don't need your praise. Damn Australians. Did I say that? I did say that one. Just kidding. OK, so let's move on to something that I think is really, really interesting. Full text search. I had to dive into this. I mean, I know about full text search. I've used full text search before, especially with Postgres. But mostly what I've done is I've just put full text indexing on a column or on a blob of text and said, OK, I've got a full text index. Now query it. And I'll just send it a term, and then I'll get back some results. But I've never actually dove in to figure out how it works in Postgres, and I'm about to do that now. I can tell you guys are excited because you love this kind of thing. All right, so the first thing I want to show you is in my save function. In my save function, I'm taking in 2 things. I'm taking in the name of the table that we're going to save a document to. Then we're taking in the document itself, doc. That's it. So this is a function body. You've seen this before. and then I'm returning a chunk of JSONB later on. I'm also taking in a third argument called search keys. And those search keys are commonly indexed keys, for lack of better words, that people might want to index. So I'm making this judgment call. It's kind of an opinionated judgment call. So when you pass in a document, what I'm going to do is I'm going to loop over all the keys in the document, and I'm going to see if they exist, and then I'm going to do something with them. And that something is down below. I am doing a loop in a function over some keys that are passed in as an argument. Yeah. I'm checking to see if the key exists on the document. And I can do this using the question mark that you see right there, body question mark search key. That is the exists operator within Postgres. Does this key exist on this document? If it does, I'm pulling it out. I will talk about that notation later on if it's unfamiliar to you. I'm pulling the value out, and I'm setting it in the search term variable. And then down below, I have to make some judgment calls here because I don't know what you're sending in. It could be anything. But if it's an email address, we don't want that @ sigil in there because it's going to mess everything up. Maybe you just want the person's name, or maybe we want their domain. So I want to strip out anything from an email address. I also have other things in there about web addresses and so on. This is really, really hacky, I guess is the best word. But it brings up the idea about what do you want in your search index and what do you want to do with it. So I had to address that a little bit in here. And finally, at the very, very end, down below here, this is where the good stuff happens. Once I loop over everything, I'm going to concatenate and build out this variable called search params. That is going to be a string of text, or it's not. And then I'm just going to update my search field, and I have to set it to tsvector. I'm going to talk about what tsvector is in just a second. But to do that, I'm going to use the toTsVector function inside of Postgres. And so then, boom, that's it. So it updates it, sets it on the fly. So in here, what I'm showing you is I'm making some opinionated judgments about what is going to be stored as full text sitting alongside your document. That is completely overridable. You can pass in whatever you want as a text array into this function. But I'm going to set that, I think, as a configuration later on. I'm not too sure. Also, as far as performance goes, I need to put this under performance check because I'm not sure how much that loop matters. But anyway, it's just something to throw against the wall because what I want is I want an experience that looks like this. Let's go and play with Velzy. And again, I'm very focused on user experience with this. If you want to save a document, this is what it looks like, velzy.save. All the functions that I showed you before live inside of a schema within Postgres, so it's isolated from your tables and everything else. So to get at it, you say velzy dot, schema dot, and then you execute the save function using select. Here I'm specifying that I want this document, goofing around with Postgres, to go into the NDC table. The NDC table doesn't exist yet. So when I execute that, it executes quite fast, and then I get back the document with the ID. Hooray. Now what I want to do is I want to be able to search that immediately. I don't want to mess around. I don't want to have to go tune an indexer. I don't want to have to go spin up Elasticsearch or whatever. I just want this ready to go. And there it is. Not only do I get back the result that I'm looking for, but I also get back a search rank. And that rank is a little bit, I'm not going to talk too much about it, but that rank is a relative rank between 0 and 1.0. And it just ranks it according to the other docs in terms of relevance. Now, I only got 1 back, but if I had like 5 back, I'd want to sort by that rank. And I do all that for you in the back end. So what is this tsvector thing? You've heard me talk about it a couple times, and I found this to be fascinating. I always just kind of said, oh, it's the way Postgres indexes documents, and I've kind of just let it go. But I recently had to dive in because, to me, just throwing text at a search engine is not good enough. You have to know what's going in there because sometimes you might want to prioritize it. You also know how it's need to know how it's going to be queried. So let's take a look at tsvector. And what I can do here is I can just select the function, toTsVector. And what I'll get back is what Postgres is doing to the string, or the corpus of text, as it's called. I can see what's happening to it. And this is really fascinating. This is simply key value pairs, where the key is a lexeme. And the value is its position in the phrase, or whatever you're sending in. I should say text. So here, goofing around with Postgres, around is in position 2, goof is in position 1, and then postgr is in position 4, and with is ignored because it's a noise word. A lexeme, this is interesting, a lexeme is the essence, if you will, of a word. So you can have like goofing, goofer, goofy, goofs, whatever. Strip off what are called stems. Strip that all off, and then you end up with the core of the word called lexeme. And so this is what gets stored, and that's how Postgres will do matching against it. So to show you how this works, I wanted to share with you that I was looking online to see if somebody might have created a script. This is so funny, that would scrape the talks from NDC here. And sure enough, Aaron Powell, who's my compatriot at Microsoft, took a script from Jake Ginnivan. Does anybody know how to say his name? Oh, he's over there. Hi, Jake. You going to let us know how to say your name? You know, he said something. I can't. I'm gonna say both in my head. No, he said Ginnivan. It's Ginnivan. I was joking with him last night about this. So anyway, he wrote this, and you can say thank you for helping me with my demo today. So I scraped all the talks here, and I scraped off the presenter's name and then also the text of the talk, and I put it into the database here using the save function. So every time it went in, it did its little magic, but it also chunked out all of the text. And so I said, I didn't actually tell it anything. It just used name and it used title, and it automatically scraped that for me. And so this is what I ended up with. And I want to zoom in on that a little bit, because you can see the very first talk there, the very, very top. This is what Heather Downing's keynote looks like when it's chunked down to lexemes and their position. And it's interesting. I was looking at this like, wait, her talk was the feeding and care. So why is that position 5? It's like, oh, right, because her name got slugged into my text. So anyway, my whole search string, it's Heather Downing, the care and feeding, whatever. I can't remember the rest of it. But that's why it looks like this. So the interesting thing to me there is the second word, down. And this right here should make your brain go, wait, doink. If we're talking about a lexeme, how does Postgres know what word we're talking about? Because downing is Heather's name, right? But down is a word that could mean something else entirely. Uh-oh. So what do we do about that? And I'll tell you in a second. To actually work with TS vector and work with full text indexing inside of Postgres, you need what's called a TS query. This is another type. Thankfully, you don't need to know how to make one. It'll make it for you. All you have to do is use the toTSQuery function and pass in whatever it is. So the term of the search. So in this, I'm going to talk about the body and the arrow stuff in just a little bit. Here, I just want to see the name and the title of all the JSON documents that I have from my NDC table. And that @ symbol right there, just as a comparison operator, just says where the search and the query match. That's that. And so boom, I get back a bunch of columns here that talk about, that fire on the Azure keyword. So Dan, Nellie, Lace, Brendan, Pratik, all of them are talking about Azure somewhere. Unless, I don't know, one of the speakers' names, there's nobody named Azure in there, right? Because that would be a false hit. So how does that actually work? Let's take a look at toTSQuery Azure. Let's see what it does. Does anybody have a guess? It just chunks it down to a lexeme. But here we don't care about position because it's just a single word. And so now we can see how Postgres actually matches against TS vector. It just looks for matching lexemes. And then and from that point on, you can do different things to it. Now I mentioned before, like with Heather's last name, Downing, we might want all of that. We might not want it set to a lexeme. We might also say, well, it's a name, so we want to up the weighting of it. You can do all of that, and I thought about diving into that, but it has to do with indexing. You have to know what you're indexing, but you can tell it, don't strip this down. This isn't a word that is strippable that you can remove a stem from, and so Postgres will do that and say, okay, I'll just leave Downing in there as a word, and then you're good. Here we can see that Azure is taken down to AZUR because it could be Azure Right, it could be Azure's, it could be all kinds of things. You can weight this, you can change this, you can add all kinds of things if you want to tweak it and get your indexing right. In fact, one of the cool things you can do is you can specify what language you're working with. You know, obviously, I've been using English, but you might want to use a different language like Australian or perhaps French. So here, I'm just telling the database that I'm super cool, and it'll do the right thing. It'll go in and say, well, chouette, if we remove the T and the E, there's our lexeme, and same with vache, which means cow. Okay, let's take a look at seeing if we can find Heather, because I find this interesting. You've seen this query before. We're just going to run this query and hope for the best. 2TS query, Heather Downing. Let's see if we can find our keynote speaker. And unfortunately, we get an error that just about everyone runs into when they try and use full text indexing. And this is infuriating. Why would Postgres not turn this into a query that we could then use? And the answer is that it doesn't know what you're trying to do, which is weird. Like, why? You'd think I'd be able to match against more than one word. And indeed, you can. But more than one word, is it just a bunch of words? Or is it a phrase? Is there structure involved? Are you trying to match against text? Are you putting in an actual literal string that you expect to be matched precisely? Or does it have to match in terms of position? So Postgres makes this a little bit harder on you. But that's OK, because we can get around this. We can tell Postgres that this is just a plain string. And we do that using a different function. And we can do plain to TS query. And this is usually what people will tend to do. So what Postgres does in this case is it will chunk those words down into lexemes, and it'll apply a logical and. So both of these words now need to be in there, Heather and down. So if we run this, boom, we get to see Heather. Yay! That's an awesome keynote, by the way. So yeah, that's how we'd fix that problem. So now we can send in more than one word, and we can treat this as a bunch of strings. It doesn't really matter. They just all need to be there. OK, what if we now look for somebody else? I'd show a picture of Troy, but I think we could all agree that maybe we've seen his face too much. Did I sound jealous? Just kidding. I have to poke fun at Troy. I just have to. You can't have a talk if you don't poke fun at Troy Hunt. All right. I guess that wasn't funny. Here I'm saying I want to use a different function because the positioning matters. What I have here is Troy and a last name Hunt. So Hunt needs to appear after Troy. So I can say to Postgres, this is a phrase. Even though it's a name, it's a phrase. And so what Postgres will do is it'll use a different operator. Instead of a logical and, it'll use a positional operator. So here you can see the arrows. And now it's expecting Hunt to appear after Troy. And so I get the result back. All right, let's try something more interesting. What if I do a phrase to TS query to say that we're going Troy hunting? So I go hunt down Troy and find him, and well, you can see what might happen here. It's going to chunk this down to lexemes. It's going to remove the ing stem, and yes, we're going to get Troy Hunt back. Is this what we want? Well, no. Troy Hunt is his name, and we should be able to tweak this index. But it's also nice that we have this ability to do positional arguments. I'm just assuming that that's going to be Troy's reaction if he hears about my demo. Did you know it's weird, it's crazy that there's a Troy emoticon. I didn't know they had such a thing. But what if we wanted to say we wanted to hunt Troy now? So this gets really interesting, this query to me, because maybe you're thinking that the speakers that are going to be speaking might have like their last name comma first. Hunt Troy, why not? Or maybe we are literally going to hunt Troy. Either way, we're not going to get anything back if we use phrase to TS query because Hunt needs to appear after Troy. It's so crazy when you get into this stuff. It's actually super relevant too because we have to build search indexing, don't we? Even if you're using something like Elastic or any other kind of search engine out there, Algolia, you have to think about these things and how you want them treated. OK, well, if you're using Postgres 11, version 11, which came out last year, they have come up with something that solves or tries to solve this problem. Web search to TS query, and this is pretty neat. So what web search tries to do is it tries to gauge what exactly the person who's querying is looking for. Maybe it's a person's name, maybe they put in some punctuation, maybe they put in a question, who knows? But here, we're going to get back the response that we'd expect. Hunt, Troy, Troy, Hunt, even try hunting, whatever. Web search to TS query is supposed to be forgiving, but it's supposed to be something that's a little bit more logical than everything else. That's all I know about it. I haven't used it all that much. Basically, what I'm trying to say is this is a bit of a dance. Getting this right. I'm not trying to say it's too hard, but the cool thing is that Postgres gives you all the tools that you need to execute really solid queries. And I know for like web search in an application, you tend to just want to have a broad thing, like you're going to guess. It's not going to be right all the time. But if you're doing something like analytics, you really want to be able to go in there and fine-tune exactly what you're looking for. OK, Now let's go off the rails to a foolish thing that's absolutely crazy that you're probably gonna throw stuff at me, which is great because I enjoy that. Let's try and do a query where we just pull out the name from our table and we try and do a fuzzy match, let's say on the speaker's name. Here we can just pull a name out of the document. You can pull any key you want out by using the JSONB column name, body, and then the double arrow syntax is going to pull it out as text. So because we do that, that means that we can then operate on it with any kind of query functionality we want within Postgres. So here you can see all of our speakers. If I use the single arrow, just to point this out, it treats it like JSONB. So if you have nested documents within a document, for instance, or keys that are also further JSON, you can select those and keep on going with the arrows until you get what you want. OK, well, let's say that I want to find all the talks where the speaker's name starts with Damien. And this is just an I like or like query, case insensitive, where I'm looking for Damien's and I'm using the percentage wildcard flag. And so here, boom, I get back pragmatic DevOps, how and why, that's Damien Brady, and then hidden gems in .NET Core, which is Damien Edwards. So those are coming up, that's neat. But this kind of syntax doesn't really work well for DBAs, because DBAs, when they see this, they'll probably come pounding on your door and saying, look, we have a table with zillions of records. It's going to keep growing. If you keep doing this, you're going to slow our system down because you're running what's called a sequential scan. I think in SQL Server it's called, I totally blanked. Someone shout it out if you know, full table scan, something like that. Anyway, the idea is that you're going over every single record. You're not using an index, and you're running that comparison. That query is going to be fast in the beginning, but as the records grow, then it slows down until it kills your system. We don't want that. We want to be able to use an index. And that is a problem when you're using JSON inside of Postgres. Yes, you can index the JSON, but it gets indexed in terms of the key, not the value. And so that means that we can't run very highly efficient queries, which is a bummer, unless you're a complete hack like me. This is just Postgres. We should be able to do something about this. I want to run a function, starts with. I want to run that function, and I don't want to think about anything else that's happening. Show me everything in the NDC table, and the name key that starts with DAM. So I made that function, and here it is. And it works pretty well because I have the one really bad thing right there in the middle. Perform Velzy create lookup column, and you guys can probably guess what's coming. Because at the very end, I want to be able to execute this query down below, this I like query, and I want a column to exist, and I want to flex the power of Postgres. This is my create lookup column function, where I'm doing a bunch of bad things on the fly. I'm checking to see if the column exists. And if it does exist, or it doesn't exist, I'm altering the table and I'm adding the column. And then I'm updating that column with all the values that are in the key that you're looking for in all the documents in the table. And then I'm creating an index. I'm using a B-tree index. So I'm creating an index so you can do fuzzy lookups. And then finally, I'm creating another trigger. Again, this is just me being a fool. I'm trying to figure out how this is going to work out, but I want to try it. Oh, I can see he's taking a picture of it. I'm dead now. It's going to end up on Twitter. I'm watching you. Go ahead. It's all right. I don't mind. So this is my create lookup column. This is absolute bonkers craziness. But again, this is the experience that I'm going for. I want to show you when you're doing, this is how we're in P-SQL again. If you do \d, it is describe. Describe this table to me, and you could see this is our basic table that we had from before. We have search, we have our timestamps, we have our body, and so on. I want a developer to be able to just say, select starts with, and boom, get their stuff. And not have to worry about not using index, not have to worry about the DBA coming and pounding on their door. That's all I care about at this moment. I don't really care that there's a trigger. That trigger, by the way, I kind of glossed over that, but it's just simply updating on any change. It's making sure that this lookup column is in sync. If we go back and we take a look, again, /d, NDC, describe our table to us, you can see that I now have an additional column in there. It's just a text column. I now have another index that's B-tree that's going to help me with this search. And finally, I have my trigger. This is supposed to be development only, obviously. You do not want this running in production. I know that kind of like AutoMapper, this is kind of a ticking time bomb in waiting. I know people run into problems when they have tools that allow them to do crazy things. But in my case, I'm just trying to be helpful. And this is the key. This is the key here, that this is a development time tool. that builds itself, as well as trying to be a backend that loves you and cares for you. You're supposed to use this to build out your table schemas, and then also, if you need to add additional columns because you want to do other queries, you can. Lock it down, and then when you're all done, deploy it as you need to. And so that is my goal here. This is kind of a database that builds itself. That's what I was thinking, at least. That's my excuse. But I don't know, it works. I kind of think it's fun. OK, so let's skip ahead. Let's say you've used Vue, and you've created your radical application, and you've made it, and then you've bounced it off Velzy in the back end, and you've built out the schema that you need to accommodate your app. And you're feeling good about this. Maybe you have auth built in, everything's wired up. Maybe. Now what? How do we get this thing live? How does it work? Well, at the end of the day, we're just talking about Node, and we're talking about Postgres. That's it. And that, to me, is the best part. So I've actually tried to build some deployment help into the thing where it tells you how to do things for free. And so one of the things that you can do is that you can stick these things into a container and deploy them wherever you like. It just happens that Azure, since I work on the cloud advocacy team, words, one of my tasks was to figure out how to build out something for free using the multi-container deployment just right on app services. And I was able to do it, which is really fun. You can build your own image, push it to wherever you like for both Postgres and for Node, have your application be just the way you like, push it up to Docker Hub, for instance, and then when you're ready to go, you can then use this Docker compose.yml file that I have in the root of the project. You just replace it with your own image names. And then when you're done with that, you can then copy and paste it right here inside of the portal and then hit go. It'll pull your image down. Every time you change the image, it'll update. It'll pull your image down. You'll have a running set of Postgres. You'll have running Node app, and you're good to go for free, the F1 tier. It works pretty well for development. You probably don't want to do anything live in that sense. If you want to see more about what I'm talking about, I also do these things called Azure Casts. You can find them on YouTube. Episode number 8, I did creating free multi-container deployments using Docker and Linux. And that's number 8. You can go watch that if you like. I also was playing around with a deploy to Azure button, which I wanted to put somewhere on the app, but I still have a few more things I want to tweak. This uses what's called ARM templates, Azure Resource Management templates. Anyway, you click a button, it orchestrates everything up on Azure for you, pulls the things down that you need, and you're off to the races. Now, I think that's neat. But I don't think that's all that compelling. Because what I want, as I keep saying, is I want a CLI kind of experience. I want you to sit down and crack out a back-end app as fast as you can crack out something on the front end using like the Vue CLI. So in that sense, I want you also to be able to deploy it. My idea, and I haven't made this yet, my idea is that you do deploy whatever's in here, and it's going to go up to Azure or wherever you set, and it's going to create the resources that you need to run this thing. The nice thing about this is if Velzy owns a deployment, it can give you a choice. You can do it for free if you want, or you can do it super scale. You can do it on app services where you link up Node apps and whatever that have a scaling plan. You can also do managed Postgres, which I don't know if you know, but we do managed Postgres now. This is actually one of my focuses, is to help the Postgres team build out its management capabilities, and it's really fun. But you can now have it hosted, and you can have a super scale backend just with a click, ideally. That's where I'm going to go. I also have CLI scripts because I'm a huge CLI fan. So I created some CLI scripts that can do this. Right. This is all in progress. This is all me having fun right now. I've been at it for about 4 months. I showed it to a couple people internally, and they're all very interested, and they're hoping the best for me. They all said the same thing. Let's see what happens. I'm like, OK. So I'm going for it. If you're wondering, oh, by the way, I still have authentication that I need to build in. Also, I need to lock this thing down with rules and permissions. I have this plan sketched out. I just haven't done it yet, so I'm getting there. If you're wondering what a Velzy is, it is this guy. It's Dale Velzy. He was one of my heroes. He's a surfing legend from the 40s and 50s. Created the very first surf shop under the Manhattan Beach Pier in Los Angeles. They used to make, this is crazy, they used to make surfboards out of these massive planks, and they'd laminate and glue them together, and they'd plane them down by hand. That's Dale on the left over there. and I think that's Tom Blake on the right. I'm not sure who that is, but these are pioneers. These guys are legends. But anyway, they'd plane down these huge planks. They would weigh 80 pounds, and they'd carry them to the beach and throw them in the water, and I don't know, hope for the best, I guess. But what Dale came to realize is that you can do something like this, but with lighter wood, like balsa wood. So he actually pioneered the use of balsa wood to make it lighter and easier for people to go surf. And then a few years later, he joined the foam revolution by helping to shape some of the foam boards that you see in all the old surf videos. That was his design. That was the tank, the big old long gun. That's Dale Velzy. So anyway, I figured it kind of was appropriate for what I'm trying to do here, just trying to make something lighter, faster, and more fun. All right, well, that's it. I do have some time for questions if you guys are nice to me. And if you need to get a hold of me at all, there's my Twitter and my email and my blog. And I'll be blogging about this too. Thank you so much. That's it. Shout out some questions if you want to. I'm sorry for making fun of you. I was told, Jake said it would be a good idea to make fun of the audience because they like it. And he said, okay. All right, well then get out of here.